Welcome to The Explainer. So glad you're here because today we're diving into a forensic re-examination of literally one of Earth's greatest cold cases. We all know the classic story, right? A giant rock from deep space slams into the planet and wipes out the dinosaurs in this huge fiery apocalypse. Well, hold on to your hats because we're looking at some fascinating source material today that completely flips that script. We're going to explore a controversial framework, arguing that the famous asteroid that killed the dinosaurs is actually not what scientists have long believed it to be. Just look at this question on the screen. What if the asteroid that killed the dinosaurs didn't come from space? I know, it sounds a bit like science fiction, right? But the source text we're breaking down today lays out a really structured, physical argument that challenges the most famous extinction story in human history. Our main focus for this explainer is to figure out exactly why this alternative model thinks the asteroid was something else entirely.
Okay, let's dive into this. Section 1. The standard asteroid story.
So the standard model we're all taught rests heavily on this one concept, uniformitarianism. It's a massive word, but it basically just means that the slow, gradual geological processes we see happening today, things like erosion, gentle sedimentation, local volcanoes, are the exact same processes that shape the Earth over billions of years. Basically, if a river is carving a canyon at, say, 1 millimeter a year today, uniformitarianism assumes it carved at that exact same rate for millions of years to get that deep. It totally relies on the present being the absolute key to the deep past.
And when you apply that uniformitarian logic to the dinosaur extinction, it looks incredibly clean. Geologists found this very thin global layer of an element called iridium at the KPB boundary. Now, because iridium is super rare on Earth's surface but really common in space rocks, the logic goes that an iridium spike absolutely means a massive asteroid hit the Earth. And that asteroid points directly to the Chicxulub crater down in the Yucatán Peninsula as the definitive impact site. Boom, case closed, right? The dinosaurs died and a 10-kilometer space rock pulled the trigger.
In this widely accepted framework, literally millions of years pass between the different layers of sedimentary rock right beneath our feet. So when sudden, crazy geological anomalies do show up, they're treated as isolated local occurrences. A local flood over here, maybe a local landslide over there, all separated by immense, unimaginable gulfs of deep time. It's a really cohesive way to view history, for sure. But our source text argues that it relies on an endless pattern of coincidences to actually protect its conclusions.
Which brings us to Section 2, the UTGH catastrophe framework.
UTGH stands for the Unified Theory of Geologic History. It was developed by an independent researcher named Darrell Waters, kind of building off the hydroplate theory by Dr. Walt Brown. Now, UTGH is a catastrophist framework. What that means is, it proposes that while the Earth itself might be billions of years old, its current surface features, the sedimentary layers, the way fossils are distributed, all of that is the result of a single, massive, global rupture event that happened roughly 5,300 years ago.
And this brilliantly illustrates the fundamental difference in how these two models read the exact same Earth, where uniformitarianism looks at a vertical dinosaur bone stretching across multiple rock layers and says, okay, that's a localized, special case anomaly that happened over a really long time. UTGH looks at it and sees a cluster of bones quickly buried in a single catastrophic wash of sediment. It's the exact same physical evidence in the ground, but two completely different interpretations of time and mechanism.
So you're probably wondering, what exactly is this rupture event? Well, the UTGH framework argues that a massive subterranean reservoir of supercritical water catastrophically decompressed. The physical math proposed by the source text suggests that a truly mind-boggling amount of mass, 10 to the 22nd power kilograms, was explosively expelled from beneath the Earth's crust. Because of this, massive tidal waves of water and sediment supposedly swept the globe, rapidly laying down the sedimentary rock layers we see today through a process called hydraulic sorting. That's where heavy materials settle first and fine materials settle last, all happening in a matter of days or weeks, definitely not millions of years.
Moving on to Section 3, Earth's ejecta, not space rock.
Now, here is where the source text completely flips the script on us. Uniformitarianism says the Chicxulub crater was caused by a huge rock falling from deep space. UTGH, on the other hand, argues that the crater was definitely formed by a massive impact, but, and here's the kicker, it wasn't a rock from space. It was Earth's own terrestrial ejecta. Part of that massive 10 to the 22nd power kilograms of mass blasted into the atmosphere during the rupture actually followed ballistic arcs and crashed right back down onto the planet. This right here is the absolute heart of the argument for why the asteroid that killed the dinosaurs is not what scientists believe it to have been.
Let's break down the mechanics, because they're absolutely crucial here. UTGX proposes that when this rupture occurred, it launched material way up high, right above the atmosphere.
The densest fractions of this ejected material, we're talking massive chunks of deep Earth rock and metal, inevitably had to fall back to the surface. The framework's models suggest this ultra-dense material was actually deflected northward as the Earth turned, eventually slamming into the western equatorial Atlantic. And that returning Earth mass is exactly what formed the famous Chicxulub structure. It literally mimicked a meteor strike perfectly.
This ties directly into the famous Hell Creek Formation in North America. That's the specific sedimentary layer right beneath the KPG boundary, where T-Rex and Triceratops just abruptly disappear from the fossil record. Now, uniformitarianism reads this as a long timeline marking an extinction. But the UTGH framework reads Hell Creek as a snapshot, a sudden, violent hydraulic burial of these massive creatures during the floodwaters of that rupture event, happening just before the densest terrestrial ejecta crashed back down from the sky to form the layer right on top of them.
Let's look at Section 4, Reinterpreting the Iridium Spike.
As you probably know, the entire asteroid theory basically rests on iridium. Iridium is what's known as a cytophile element, which just means it really loves to bond with iron. Because of that, it's super rare to find on the Earth's crust. Most of Earth's cytophiles sank way down into the deep mantle and core a very long time ago. But they are highly enriched in meteorites. So when geologists found a global spike of iridium, space rock was the most logical conclusion. But here's the catch. Cytophiles are also highly enriched deep, deep inside the Earth.
UTGH is totally on board with the fact that the iridium anomaly is real and physically present all over the world, but it argues the standard model got the origin story backwards. UTGH proposes that the iridium came from deep Earth material violently dredged up from the mantle during the rupture event. As this mantle-rich ejecta rained back down across the globe over a period of time, it deposited that famous thin layer of iridium. Basically, the murder weapon didn't come from above our atmosphere. It actually came from miles below our feet.
Now, what's really interesting about this slide is how UTGH attempts to unify geology. Instead of requiring a separate special asteroid impact to explain the iridium, and then a separate ice age, and then a separate set of local floods to explain buried dinosaur bones, UTGH offers one singular physical mechanism. It treats the KPG boundary, the Chicxulub crater, and these mass fossil graves as simultaneous consequences, all cascading from one massive, catastrophic rupture. And finally, Section 5, Falsifiable Tests and Predictions. The UTGH framework doesn't just sit back and make wild claims, it actually makes very specific, falsifiable predictions. The text proposes that scientists should analyze the isotope ratios of osmium, iridium, and ruthenium right at the KPG boundary layer. And the truly amazing thing is, the physical samples to do this already exist. Cores from places like Gubbio, Stevens Clint, and even the Chicxulub crater itself have already been pulled up. Plus, the analytical technique to test them is completely standard laboratory procedure. So here is the ultimate scientific showdown presented by the source text. Space rocks, specifically chondritic asteroids, have very distinct isotope ratios. Earth's deep mantle has different, distinctly terrestrial isotope ratios. If scientists test the KPG boundary layer and the ratios match an asteroid, well, the UTGH framework is instantly falsified. It just loses. But as the text points out, this specific question hasn't really been asked because the asteroid hypothesis was already widely accepted before this kind of test was even formulated. But man, if those ratios are tested and they actually match the Earth's mantle, the standard model is going to face a massive crisis.
Which leaves us with this final, incredibly striking thought to ponder. Now, we're just reporters here, explaining what's in the text, but you got to admit the implications are staggering. If those existing core samples are put under a mass spectrometer tomorrow, and the chemical fingerprint proves the dinosaur-killing material came from inside the Earth rather than outer space, how much of the textbook history of our planet would we literally have to rewrite? It is a brilliant reminder that in science, the case is never truly closed as long as there's unexamined evidence. Keep questioning, keep learning, and hey, thanks so much for joining me on this explainer.